SwayamPrabha. Digital India. Educated India.
Welcome back. In lecture 28, we will look into residential mobility model using binary logistic regression. So, the two things that we will cover in this particular lecture is residential mobility model using binary logistic regression and SPSS, and residential mobility model using Python. We will do the same binary logistic regression using Python as well. So, SPSS is a statistical package for social science, and this was developed during the 1968 and then eventually acquired by IBM in 2009. And SPSS is a very popular statistical software which are used by in many institutions, and it's easy to use as well. And the data file formats compatible with SPSS are spreadsheets, like Excel, then text files or relational databases, or Stata and SAS, which are other softwares as well. And SPSS can be can open the file formats that has been listed there, as well as we can edit the data files, create tables, charts. We can analyze the data based on different statistical models that are already inbuilt into that, and then we can save the output in different file formats as well. And SPSS also offers extension to with Python, and RStudio. Both Python and RStudio is free, and that Python is basically a programming language, and R also is a statistical package where you can do a lot of scripting or programming. But I have in this particular lecture, I am going to cover logistic regression using both SPSS, which gives a very ready-made or very easy to use access to the statistical tools that are there. But we have to buy this software, and you can always, it is downloadable for evaluation free of cost, of course, but eventually you have to buy. And I am also going to explain using Python the same code, the same regression that is done with SPSS. But again, for using Python, you have to have some basic knowledge of computer programming, and it's very easy to learn, and the part that we will actually use is very limited, requires very limited programming knowledge. So I hope that people would be able to do both SPSS as well as Python. But people who cannot eventually buy SPSS, they have to rely on something like Python or R, and I would suggest to go for Python, because you will also learn a language which could be used for many other purposes. The current version available for SPSS is 25, and you can download from this web link. You can actually download from this particular web link, and you can try SPSS statistics for free. You can create a trial account, and then you can download, and then you can eventually, your institution, or you can buy it, or you can just use the trial version for to learn the different aspects from this particular course. So first we will discuss the model itself. So we are developing a residential mobility model using binary logistic regression in SPSS, and the data set that we will use is basically our intent to move survey. It's a stated preference survey that we had conducted earlier, and we have talked with the household head, and we considered him to be the decision maker. We have talked with him and got his feedback, but we assume that the feedback he is giving is basically the feedback of the entire family, and that's why we say that household head is considered the decision maker. But eventually the decision may have been, many people may have contributed to the decision, but we are asking him that where he, if he is willing to move or not. So that's why I am saying household head is considered as a decision maker. So decision dependent variable is y, which is decision to move, and 0 is like people will stay in that particular area, and 1 is willing to move from present location. So these are the two options that are available with us. So that's a binary choice. So on the left side, we can see the different variables that we have used in our model. So for example, we have considered the monthly income, number of members, age of the household head, marital status of the household head, is he married or not, and the gender of the household head, is he male or female. And these are the household characteristics that we have considered. Then we have also considered, the education of the household head, the occupation of the household head, where he works or what he does, what is his education level, and family type, and number of children in the family, number of workers in the household, housing type, ownership type, tenure, ownership is tenure, person origin, that is he a migrant or not, so local one or migrant, and ownership type you can see owned or rented, housing type is plotted or apartment, family type is nuclear and joint. So in this way you can see the different categories that we have used. So these are all categorical variables that we have used, and then there are some continuous variables as well. So car ownership, again it's a dummy, it's a categorical variable, yes or no. Reasons for moving, there are again 4 categories are used. Work is the reason, primarily housing, family, personal preferences, and so on. And then reasons for, then walk time, that is the total travel time to work, that we have considered, it's a continuous variable. Then we have used some parameters like housing quality, neighborhood quality, proximity to social infrastructure, proximity to transport mode. So we have not given any description for that, because these are actually factors. That means we will discuss factor analysis in detail when we do mode choice, hybrid mode choice models later on. But what I can tell you is lot of decisions depends on human perceptions. That means people's satisfaction with certain things, or people's intention to do certain things. So this could be captured using several other parameters, and many of these parameters influence the final consideration. For example, housing quality, it could be composed of multiple parameters, but instead of taking all those parameters separately, because these are all perception type of parameters, like people have given satisfaction rating for in a 0 to 5 in a 5-point scale or a 7-point scale. So you can understand if perception parameters are taken, and these are not continuous variables, so each one of them are individual categories. If person has given satisfaction rating of 1 or 2 or 3, so this has to be dummy coded. So that means if he has given a satisfaction of 1 or 0, or satisfaction rating of 2 or 0, so 2 is 1 or 0, so each one has to be dummy coded. So it increases the number of variables in the equation, and sometimes it's unnecessary as well, and sometimes based on this perception choice process, we will discuss that later on. People have those logical constructs which actually which is made up of many variables. So we determine using factor analysis some factor scores combining all these parameters, and we can use them directly in our model. So that is what has been done over here, and this is like all these things have been derived from satisfaction ratings through factor analysis. And finally the decision to move, which is stay 0 and move 1, which is a nominal variable. Sorry. So before we even start with developing the model, we have to do a lot of pre-processing. We can also call it the data cleaning process. We have to make sure that there are no missing values for any of one of the variables. If missing values are there, then we have to reconstitute those values from the existing data set or from some other variables, like if there are some relationships existing. What this means is either we can put an average value for that particular variable in that particular group, or it could be based on certain existing scatter plots that we have developed for this particular variable and the decision variable. So some way we can fill up those gaps. And then outliers needs to be detected and removed from the data set, which can be detected by plotting dependent variables versus independent variables, and then using statistical measures like standard deviation. That means we take the mean, and beyond 3 SD we can remove some of the variables, because sometimes some variables could be close to the distribution, but some variables are very, very far away because it's an odd case. So that will actually skew my results. So it's better to get rid of that. So that's why we can get rid of the outliers. And in case of software packages that require certain custom scripts for performing regression, the data needs to be imputed in fixed format. inputted in fixed format. What it means is, based on the input requirement of a particular software, we have to create the data file. Either it could be a CSV file, or it could be a .dat file, or it could be a JSON file, which is related with, again, databases. So measure and scale of each variable should be also correctly defined. So this is the, when we open SPSS, this is, we can, there are two views you can get. One is the data view and the variable view. In variable, this is what you are seeing is the variable view. These are the, once I have loaded my Excel file, which includes all the data that I am using for this particular model. So we can see that these are the different variables that we are using. You can see the list of variables as we have discussed from the last, in the last slide, in the last to last slide. And these are the different variables. Some are numeric, some are string, and so on. And then these are the measures. Some are scale measures, continuous, some are nominal measures, and so on. So this is where you can look at that. Then clicking on the data view, you can see the data. So I will just run this small video. So first we have to click on the data view, and then we have to click on the analyze menu option, where we will get the option of regression, and within regression we have to choose the binary logistic regression. And when we do that, this particular window pops out. Here we have to choose the variables that we are going to use in the equation. Now that the this variable has, we get this window, the next step is to decide on the dependent variables and the independent variables, and that is what we have to do in this particular window. So we first choose the dependent variable, which is decision to move, and then we have to choose the independent variables. So some of them are covariates, and like social, this walk travel time, the person origin, this is a dummy variable, this is a continuous variable. So all those variables are put in the covariate box. And then all the categorical variables, that means where we have got different categories. For that we have to click on the categorical button over here. So once we have entered all these covariates, we click on the categorical button, and there we have to include the categorical variables. So some of this, like monthly income, marital status, these are all categorical variables. And once we have selected that, then we can first determine that what kind of what would be the reference category, and accordingly then we can choose the different statistical estimates, like correlation has to be included in the model. And once we have chosen all these factors, we can create all the, select the correlation estimates and so on, and then we can click to run the model. And when we have run the model, this is the result that comes out, and I will discuss the results in the next slide. So this is the, on the left hand side I have included the results screen. So here you can see the results screen. I will start from the beginning. So this is the logistic regression window. The first table is the case processing summary, which tells us about how many cases are included in our analysis, and if there were any missing cases, like some of the variables were missing and all, so those would be listed. So there were around 200 cases that are included in the present study with 0 missing values. And then the dependent variable, over here we can see that how the dependent variable is encoded, for example 0 is for stay and 1 is willing to move, so that is being given over here. So original value 0 and 1 is now coded as 0 and 1 in the model. So original value was already given, explained earlier. And then the categorical variables, the coding is also shown. That means monthly income, these are the 3 categories, marital status, these are the 2 categories, and person of origin, these are the 2 categories. So of course one in all these ones, monthly income 1, marital status 1, person origin 1 are the reference categories. So we analyze the results in reference to one of the categories. So these 3 tables, the first one presents the baseline model or the null model. That means no variables are chosen. In that case, if no explanatory variables are chosen, then in that case the 84% of the cases are predicted correctly. That means the classification table shows that if no explanatory variables are included in the model, then the model can predict target variable with 84.3% category, so accuracy. So this is based on the constant. That means we have only the constant value in the model. So when we do regression, I will explain that. So there is beta 0 plus beta 1 x1, x1, x2, x3 are the variables, beta 1, x1, beta 2, x2 and so on. So this is basically the regression equation. So beta 0 includes the effect of all the variables which are not there in the model but has a influence on the final decision. So that means if I don't even include the variables that I am selecting to be important for this particular model, just by including a constant which is actually a representative of all the variables which are not included in the model, then 84.3% of the variation could be explained. So that is what this says. Then in this particular next group of tables, what we see is the regression method that has been used. So regression model including all independent or explanatory variables. That means we have included all the explanatory variables. This method is called enter. That means we have allowed all variables to be analyzed, but of course we can give a term where we say that only variables with a significance higher than 0.05 will be there. So now within 95% confidence interval will be chosen, but it depends on the criteria. Sometimes if I feel the variables are important, we can even go for a less stringent criteria. So in that case, we can go for a 90% confidence interval as well. So the next table shows us the omnibus test of model coefficient. This shows the improvement of the new model with explanatory variables included over the baseline model. So that means once we have included the new variables in the model along with the constant, is it going to improve the model or is it improvement over the existing model? So this could be done using a chi-square test, where we have found the chi-square is 107.434 and the degrees of freedom is 8 based on the variables that are included, and the significance level is lesser than 0. So that actually is a significantly better than the null model. Null model means the model which doesn't have any explanatory variables. And then we come to this R squares. These are not exact R squares in a regression equation. These are specialized R squares developed for logistic regression, like Nagelkarke R square, which shows that the present model explained around 68.9% of the variance in the particular data. So that means this is sort of R square measure which gives us an idea about the fit of the model. And then based on the model that we have done, then if I use my equations to classify, then we can see that the current model predicts around 92.4% of the cases correctly as compared to 84.3% of the previous model. So this could be seen in this particular table where decision to move 0 and 1. So this is decision to move 0, 172 is predicted, decision to move which is 1, that is wrongly predicted, 5. Over here this is 11 is wrongly predicted and 22 is correctly predicted. So total prediction percentage is 92.4. So this is the correlation matrix that is also included. So here we see variables that are included in the model on both sides, and we see how they are correlated, and this actually shows like how work is correlated with social infrastructure. So that is minus 0.328, and then work to work is of course 1, then work to person's origin, that is if he is a migrant or not, that is 0.1012. So we can check the correlation matrix, and we can say that the amount of correlation between each pair, if it is high, then we can be careful about including that particular variable. Two variables are said to be correlated if the correlation coefficient is greater than 0.5. And according to the above table, none of the variables in the model are highly correlated with each other. Finally, we come to our main table, which is the variables which are included in the equation based on my criteria of 95% confidence interval, which is given by this significance level. If significance is less than 0.05, then it is included. So that is why all these variables have been included, and the variables which are not included, because we have started with a lot many variables, so those are not included because their significance was exceeding this particular value. And so we have the beta coefficient estimates, and these are the variables which are included in the model, like social infrastructure, walk travel time, if the person is migrant or not, number of workers in the family, monthly income categories, in which category he belongs to, which income category, marital status of the household head, persons per room. So these are the factors which are helped in determining if a household is willing to move or not. So if I have a database which have got this particular data, then using a utility equation, I can develop a utility equation based on this particular result, and based on that I can run a probability. We can calculate the probability of a particular family to move in the future time period. So here is the utility equation. Utility is equal to minus 1.896, which is the constant beta 0, minus 1.67, which is negative proximity to social infrastructure, which is has got a negative sign, plus positive sign is 0.11 into walk travel time. So walk travel time increases, people are willing to move. Proximity to social infrastructure increases, people are less likely to move because we are getting all the social infrastructure nearby. Then person of origin, that means if he is a migrant, he has a more chance to move, and so on. So these are the different utility equation, and based on the discrete choice theory, we have seen that from utility equation we can also determine the probabilities of a person's intent to move. So table shows the variable coefficients p value and odds ratio. Exponential b is the odds ratio. I will explain that. And p values below 0.05 shows significant variables within 95% confidence interval. So model predicts intent to move against decision to stay, that is the reference category. And because in any logit model we have a reference category. So in compared to decision to stay, intent to move is being predicted. And person of origin, which is positively related, migrants, we see that the exponential b value shows migrants households are 6.074 times more likely to move compared to local households. So we go back over here and we see that migrant households, which is like person origin, here we go to exponential b 6.074, which actually says that migrant households are 6 times more likely to move compared to local households. And social infrastructure is, in this case, exponential having 0.188, proximity to social infrastructure like school, health markets, which was a factor I said it composed many things like proximity to school, health, or satisfaction with those values, health, market, total overall social infrastructure proximity makes people 0.188 times less likely to move. And then persons per room, again this is positive, and we have the exponential b value, which shows increase in number of person per room makes households 2.818 times more likely to move from their present location. So this could be also, this is the model how we can interpret that. The same exact thing could be done using Python. Now this is Python programming, it's a programming language. So it's an interpreted, object-oriented, high-level, general-purpose programming language. It's very difficult to cover a programming language in a single lecture. So we have this, it's an object-oriented language. That means we have this concept of classes where we create a group of functions and variables and make them into one class. And then this is a very, very popular language. It's very easy to develop code on this. And it is the fastest growing language in terms of and it has got many predefined libraries and human and friendly syntax. That means it's the coding is almost like writing normal the English language, and processed at runtime by an interpreter. An interpreter can be defined as a program that runs the scripts written in a programming language like Python. So that is the one that executes the actual code, and you can go through python.org and then download Python. And there are different versions of Python. We suggest the Anaconda version. You can select any other version as well. And Anaconda comes with a lot of pre-installed Python libraries, and it has got something called the Jupyter Notebook, where you can write your code, and Spider as the Python working environment within which you can run the code. And then download, you can link this from over here, www.anaconda.com products/individual, and you can also go through Python documentation over here. So just to give you a brief idea about the programming language, particularly people who has some basic information about or some knowledge about programming, most people do have. So whenever we have a programming language, we have to define lot of variables, because a program doesn't understand names of individuals or particular items. We have to define the variables and what kind of variable it is. For example, it could be an integer like a is equal to 3. That is how we write, that is the way how we write Python code. It's very simple. And then there could be real numbers, a equal to 1.3, collect a string, it could be a float, then it could be a string which could be a collection of words, and we include them in double quotes. And array, it could be an array, like it's sort of a group of variables. And while defining an array, assign data type followed by array elements. So this is how we can do that. Then it could be a list. It's similar to array. And then we have got tuples. These are similar to array, but tuples are immutable, whereas list is mutable. That is, it could be changed. Then we can have a dictionary. Dictionary is we specify that using third bracket, like we say that a is equal to 1, b is equal to 2, c is equal to 3. This kind of code we can write. And this is particularly important when we assign data. And then we have got sets, like again we have used this kind of brackets, and we say it's a collection of unique elements. So this is a set. So this is the beginning. And then once we define the variables, we need to do certain things with them. For example, we can run them in loops, like we can use this for and while statements, where for a variable in a particular range, we can do certain things, or while a variable is less than this, do something. So these are loops and iterations or repetitive tasks, because computers are good in repeating tasks, and this is how we can make them repeat. And there are if-else loops as well, like for example, if these are conditional statements. If something is happening, then do this, else do this. If some condition matches, then do this, else do this. And then we have got breaks, continue, pass. These are syntax which actually help us to these are control statements. These help us to actually get out of a loop or continue with the next iteration and so on. So Python uses several libraries. For example, the pandas library is used for data manipulation and analysis. It allows importing of many file formats like CSV, etc. And it also allows many data manipulation and data cleaning operations. And this documentation could be looked over here. NumPy stands for numerical Python. It allows many mathematical operations of particularly arrays and so on. And you can see the documentation over here. Then stats model is mainly built for statistics. It provides classes and functions to estimate many statistical models like linear regression, logistical regression, and these are and then comes the sklearn library. It is a machine learning library. It can help you to classify, do regressions, do clusterings, and so on. So it includes several algorithms which could be called and to act upon a particular set of data. So basically these are groups of functions which are already written. We just need to understand which function does what, and we need to understand the data entry format for that particular function. And so if I have got a data file and I call a function and include that data file inside that function, then that is what will give me results. So that is, it's similar to SPSS, only you are clicking over there, like you have a data file, you open it, then clicking your dependent variables and all, and including that, and then saying run the model. So here also, instead of just clicking, we just have to type in that particular aspects. For example, we have to select the data file, then we have to say what is variable X and what is variable Y, what are dependent variables, what are independent variables, and then we have to call a particular logistic regression and then ask for the results, and automatically it will show the results. So that is how easy it is. So you can see the code over here. So this is the residential mobility model that we have already discussed, and it's now we are using Python. So it's the intent to move survey. We are first in the Python code. This is what you have to write, and this first you have to import the libraries. We import the pandas library, and we also include the sklearn library and the stats model library. So you can directly write this code, type in this code. It shouldn't make any difference. Pandas are Python library for data manipulation, stats model, and sklearn we have already discussed. And then import the data set. That means data equal to pd.read underscore CSV. This is read the CSV file, and then we give the file location, which is users desktop nptel and mobility underscore fin .csv. So this is the file name that we are using, which is the data file. And then the next step is to select the independent and dependent variables, where we set the data frame .iloc. This is the function where we give the rows and the column indices, which actually tells us what are my x and y values. And using these values, this is y data and this is the value that we are using, and this actually relates that which variable is the 23rd variable in my list in the column is the actual in that particular row is the actual decision variable, and these are all independent variables. So this is what we have done. For stats model, bias needs to be added in the independent variable data frame. So that's why this particular value constant has to be added. So this is a bias. This beta 0 is called the bias variable, right? So that's why we are adding that. And then in the model fitting exercise, in the next part we do the model fitting. That means we run the model. So we call the function sm.logit. In stats model there is a logit function. So in result is equal to logit model.fit. First we fit the data and then we print the results. So once we print the results, this is the output that you see where it says optimization terminated successfully. Current function value is 0.179 and iteration after 9 iterations. Basically this is a log likelihood function, maximization function, and based on that the number of iterations takes place, and we find that these are the final values, where you can see that these are the coefficients given for all the variables x1, x2 to x7 and so on, and we have got the standard error and the significance values and so on. And from here again we can interpret the results in this way, and like here also the log likelihood and all the other variables are given. So utility is equal to minus 0.483, this is the constant, plus 1.067 into percent per room, this one x1. And in the same way we develop the utility equation from the SPSS results, we can also develop the utility equation from the this particular output of the Python program. So this is very easy. You don't need, as a part of this course you can go through this. This may not be a part of the final exam requirement, but this is an option for people to use or learn a little bit of Python, as well as to avoid buying expensive software. So this is absolutely free, and it gives us the exactly same results. So these are the references that you can use. And to conclude, we can say residential mobility model has been developed using binary logistic regression in this example, and SPSS statistical software and Python programming language has been both used to develop this model. Both approaches show closely matching model specifications. Thank you.